So one of the interesting things that synaesthesia brings home to us is the fact that all of our senses aren't completely separate from each other. And this is something that students who are new to psychology and neuroscience often fail to grasp, simply because they understand that the eyes are different from the ears, for example. But of course, when information from the eyes gets to the brain and when information from the ears gets to the brain, they're talking the same language in terms of the firing of neurons. There is nothing different about a neuron that responds to sound, that responds to hearing in terms of its chemical composition and the way that the neuron really behaves. It's just the actual source of information that's being processed. So these two sources of information are quite capable of talking to each other in all of our brains. And this is the way that the brain works. So if, for example, if you're listening to somebody in a crowded room, if you look at their lips, it will actually amplify the response properties of those neurons. The number of action potentials might be increased just by having a visual input. So you actually combine two different inputs in multisensory neurons. And this has certain advantages. It can help you to hear better by looking at somebody's lips, in a literal sense, not in a metaphorical sense. And it also helps us to make sense of the world as well. So if lots of things are happening in the world, what you're wanting to do is to create a model of the world in terms of whether or not that sound is linked to that particular aspect of vision. So what you try to do is say, yes, because these two things happened at the same time, they're probably connected. And there are certain rules that the brain uses to kind of infer what goes together. So things that move together are perceived as belonging together. Things that are in the same location are perceived as belonging together. But also there are more abstract principles that operate in our brains. So for example, things that are bright and things that are high-pitched tend to be perceived together. So if you're asked to make a judgment about a sound and you're presented with something that's very bright, you're going to be affected by your ability to tune into the auditory domain. So for example, if you're asked to judge whether something is high or low pitch, if you've got a high-pitched sound and you see something that's bright, you'll be faster. If you've got a high-pitched sound and you see something that's dim, you'll be slower. So hearing and vision are constantly interacting in all of our brains. Now, people with synaesthesia also show a tendency to link together the world in non-arbitrary ways. So, for example, when synaesthetes listen to a high-pitched note, they might experience it as being bright. But what's happening in synaesthesia here is that only one sense is being stimulated, in this instance hearing, and their brains are then converting it into a conscious experience of something that is bright. Whereas in typical multisensory perception, what's happening is that two information channels are being stimulated and the brain is combining them. And that's quite different from synaesthesia, where only one channel is being stimulated and the brain is creating a whole new percept on the basis of that one input. But nevertheless, there are these intriguing similarities, that things that tend to go together in normal multisensory perception also go together in synaesthesia. So it's like the same set of rules that are there, but the synaesthetes perceive them consciously, they get them more automatically, and they're very precise in nature.